If you're watching this video, chances are you're interested in earning your FAA Part 107 Remote Pilot Drone Certification. To do that, you're going to have to pass a knowledge exam with at least a score of 70%. Now, to help you get ready to pass the exam, I made this video here compiling as many numbers as I can throw together that are all potentially included on that exam. So without further ado, let's get started. First up, I want to take a look at the different parts that are going to be contained in this video. There are 5 in all, so taking a look at part 1, and I will have timestamps for each of these, so go ahead and check the chapters on the timeline. Part 1, we're going to look at speed and distance numbers. Part 2, we're going to look at time and weight. Part 3, money and more. Part 4 focuses on sectional charts. And then finally, part 5, we're going to take a look at metar and TAF reports, which are those weather reports. And let's just jump right into part 1, speed and distance. 400 feet. This is the maximum height that you can fly your drone. So the max altitude above ground level, and you may see that abbreviated as AGL. Now, you may go beyond or above 400 feet if you are, say, doing a commercial job inspecting something like a tall tower or a building. So let's say there's a tower that is 500 feet in height. You may climb to a total of 900 feet, which is basically 400 plus the height of the uppermost limit of the structure. So 500 plus 400 gives you 900 feet as your new maximum altitude. And as long as you are within 400 lateral feet of that structure, you may stay at that higher altitude. Now, just as a reminder there, that is for commercial purposes only. Recreational flight is limited to 400 feet, no matter what. 3 miles. This is the outdoor visibility requirement for legal flight. If you are looking to fly your drone, there must be at least 3 statute miles of visibility, and you may see statute miles abbreviated as SM, and that's all part of what is called Visual Flight Rules, or VFR. So 3 or more miles of visibility, and you're good to fly. If you're flying at night, 3 miles also comes into play, that you must have what is called anti-collision lighting installed on your drone, and that lighting should be visible from at least 3 miles away. It's worth noting that the lights that are often included with drones, the blinking lights that are built into the arm, are not considered bright enough. They are definitely not going to be FAA compliant. So if you're looking to fly at night, you'll have to purchase a separate add-on or modification FAA compliant anti-collision lighting set that you can attach to your drone. Next up, 10 degrees. Now, this is for what is called sky scanning. So before you conduct a drone operation outdoors, you're going to want to take a look up at the sky to make sure that it is free of any kind of hazards or any other safety concerns like other aircraft or whatever else. So the most effective method of scanning for other aircraft or collision avoidance during daylight hours is to use a series of short, regularly spaced eye movements to search each 10-degree sector. Usually the wording will be exactly like that on any kind of exam question. 2,000 feet actually comes up a couple times. That is the horizontal distance that you need to remain away from clouds while you're in flight. And that is also the distance horizontally again from guy or support wires. Really, you can kind of just think of that as the support wires that come off of tall towers like a radio tower or something like that. So 2,000 feet horizontally away from both clouds and kind of support wires. And lastly, there's also something that could potentially come up on the 107 exam, and that is to stay at least 2,000 feet above a wildlife refuge. Now, that is obviously not going to be something that is relating to drones because of the 400-foot maximum altitude requirement. But for manned aircraft, that question could potentially come up because it is an aviation exam, and they may throw some manned aircraft-centric questions in there to mix it up. And staying on the topic of clouds, we have another number, 500 feet. Now, this is the vertical distance that you need to stay away from clouds. More specifically, it's the vertical distance that you should stay under clouds. Now, the whole reason that the FAA wants drone operators to keep their drones away from clouds is obviously just to keep them away from anything that can obscure their visibility from manned aircraft that you're sharing the airspace with. So if you have a small drone hiding inside of a cloud or near a cloud, it's going to be a hazard because it may be difficult for anyone to see that's flying up there. 100 miles per hour or 87 knots. Now, those two numbers are equal, just different units, and that would be the maximum speed limit for any kind of drone operation. Now, the same rule applies to all airspace. There are a couple questions you could get that ask you specifically, like, what is the maximum speed limit under Class B airspace? Now, it is always going to be 100 miles per hour. You just want to look out for any kind of trick questions where they mix up the units on you. So 100 knots would be an incorrect answer. 87 would be correct. And you also want to look out for like 87 miles per hour. You were looking for 100 miles per hour or 87 knots. Next up, 1,200 feet. I've got a couple airspace specific questions that we'll be getting into here. But first up is Class G or Gulf airspace extends from the ground or the surface up to 1,200 feet AGL. And you can kind of see on the diagram here, all Class G airspace is this lighter green color extending from the surface up to 1,200 feet AGL. Next is 700 or 1,200 feet would be our Class Echo airspace, beginning at 700 feet or 1,200 feet, again in AGL or above ground level. The Class E airspace here in the darker green segments, it is beginning at 700 feet or at 1,200 feet, depending on where it is. 2,500 feet would be our Class Delta or Class D airspace, extending up to 2,500 feet AGL. So the Class D airspace, which would be found around some smaller or regional airports here, extends all the way up to 2,500 feet AGL. And then next, 4,000 feet would be Class C or Charlie airspace, extending up to 4,000 feet AGL. So your larger airports around some larger cities, maybe. Not the biggest, but still bigger than Class D. So Class C here in the magenta colors, extending up to 4,000 feet, a little bit higher than Class D. And then next is 10,000 feet, which is the largest type of airports. Class B or Bravo airspace is going to be extending all the way up to 10,000 feet. And now this unit is MSL because these are the larger commercial airports or the international airports that must be kind of standardized with the rest of the airspace because of all the commercial traffic. So you'll notice that Class A airspace, which we'll get into next, is also measured in MSL. That is 10,000 feet. Next, 18,000 feet would be our Class A or Alpha airspace beginning. So all the way up at 18,000 feet is where Class A airspace begins. And this is going to be for obviously some very high altitude commercial flight operations with instrument rules. This is not going to be relating to any kind of drone operations, but it could potentially come up on the Part 107 exam. Also with 18,000 feet is our Class E or Echo airspace extending all the way up to but not including 18,000 feet MSL. So here we are at part 2, time and weight. First up, 55 pounds or 25 kilograms. So that is, for Part 107, it's only applicable to unmanned aircraft or drones that weigh less than 55 pounds or 25 kilograms at takeoff. So this entire set of rules about commercial drone operations that you're getting this certification for only applies to drones that weigh under these two limits, under 55 pounds, under 25 kilograms at takeoff. Now, what that means is everything attached to the drone, we're talking propellers, batteries, any kind of camera that you may have mounted to it, or any cargo really. So if it's a delivery or maybe something like this agricultural sprayer drone, it would include everything that's in or on the drone at takeoff. And that is an all-inclusive weight. So as long as it weighs under 55 pounds or 25 kilograms, it is considered a drone that can be flown under Part 107. Next is 0.55 pounds or 249 grams. Now, these are for really small drones, obviously. So drones weighing under 0.55 pounds or under 250 grams are exempt from FAA registration requirements, but that's only for recreational use. If you plan on using one of these smaller drones for any kind of commercial purposes, you will still need to register that drone. These drones that are really lightweight are considered Category 1, or I guess can be considered Category 1 drones, which could be flown over people, assuming that certain requirements are met. Now, that's not the point of this video. If you're interested in learning more about that, just go ahead to YouTube and search for something about flying over people, and you'll see lots of content. Next is load factor. This is about as math heavy that you're going to get on the Part 107 exam, and the odds of you getting a question like this are actually pretty high. Now, it's a little intimidating at first, but trust me, these are actually some of the easier questions that appear on this exam. What it does is it tells you that you have a drone that weighs a specific weight, For this case, we're looking at a 10-pound drone, and it's asking you what approximate weight the drone structure would be required to support during a banked turn. They're always going to tell you the weight of the drone and the degree or of the bank that you're making. And they will also give you this load factor chart in the material that you have access to while you're taking your assessment. So you can see here the 60-degree angle of bank has a load factor of 2.0. All you need to do is multiply the weight of the drone, 10 pounds, times the load factor for that angle of bank, which is 2, so 10 times 2. The answer here would be 20 pounds, but sometimes it'll be an approximation, so you may not see the exact weight, so just go for the one that is closest to whatever you calculate. 13 years. You've got to be at least 13 years old if you want to register a drone through the FAA Drone Zone website. Now, that's just to register a drone. If you actually want to get certified with your remote pilot certification, you've got to be 16 years old. So 13 to register, 16 to actually take that Part 107 knowledge exam. And just on that topic here, if you are going to sign up to take the Part 107 exam, you do need to have a valid state issued or government issued photo ID. It's got to have a photo on it. They will not let you take the test without that. The things that work for it, a driver's license, obviously, a state issued ID, a passport, or even a learner's permit, as long as it has a photograph on it. Something like a school ID with a photo would not suffice for this. And back to registration, 3 years. So let's say you register one drone. That registration for that specific drone will be valid for 3 years. After that time period, you'll have to renew the registration. 14 days. Speaking again of registration, if you have sold a drone or if you've given it away to someone or it gets destroyed or anything like that, you do have 14 days to update or cancel the registration of that drone on the FAA Drone Zone website. And that's also applicable to things like permanent address changes or any other kind of registration information that changes for you. 24 months is the validity period for the Part 107 remote pilot certification. So if you do pass your Part 107 exam and you get certified, you must complete what is called a recurrent training every 24 months to stay active. Now, this is important because if you fail to do this, your Part 107 certification status can, lapse, and then you will no longer be active, and you'll then have to pay the $175 to take the 107 exam again. So it's in your best interest to take that recurrent training within 24 months. So I'd recommend setting a calendar event for yourself just to remind yourself at least 23 months out from earning your certification to remind yourself to take this recurrent training. It is a very easy, free recurrent training that's available online, and there's no need to go to a testing center or anything like that. And it is quite easy. 90 days. This is if you want to apply for an FAA certificate of waiver. So let's say you're looking to do something with your drone that is typically not allowed, like flying within Class B airspace or flying above 1,000 feet or flying into restricted airspace, something that you're, not allowed to do typically. If you can apply for a waiver, you could possibly get approval to do that operation, but you need to apply for those waivers at least 90 days in advance of the proposed operation. 10 days. This is for any serious accidents involving a drone. And by serious, I mean that the accident with the drone causes hospitalization, loss of consciousness, or kills someone, or causes property damage that exceeds $500. If any of those kinds of things happen with a drone accident, you as the operator have 10 days from the day of the incident to report the accident to the FAA. Accident reports for drone operations are handled through the FAA Drone Zone website. 8 hours. So this is all about alcohol. A person can't act as a remote pilot of a drone or even as a crew member of a drone operation if they've had alcohol within the preceding 8 hours leading up to the operation. So you can't fly a drone and you can't be someone like a visual observer or any other kind of crew member even, as long as you've had alcohol recently. That is what is known as the bottle to throttle rule. 30 minutes. You'll see this amount of time come up a couple times here in the Part 107 exam material. So you'll see that with something called civil twilight. We get 2 civil twilights each day. There are 30 minutes before sunrise and then the 30 minutes right after sunset. Now, if you're going to fly during that civil twilight period, either the morning civil twilight or the evening civil twilight, you're going to need those anti collision lights that you kind of need for nighttime operations because civil twilight is considered nighttime operation. And just as a reminder, those anti collision lights must have at least a 3 statute mile visibility rating. And 30 minutes again here is the time that it takes for your eyes to fully adapt to darkness. So if you're conducting a night operation with your drone and you're letting your eyes adapt to the dark environment that you're flying in, you need to wait 30 minutes. And something worth considering here is if there's some sort of light, some sort of bright kind of light that shines in your eyes while you're waiting for your eyes to adjust, that timer resets. So if a car drives by with their high beams on or something and it shines in your eyes, you now need to wait another 30 minutes for your eyes to fully adjust to the dark environment. In 30 days. Now, this is the amount of time that you have to notify the FAA of a permanent address change. So you've got 30 days to let the FAA know that you either moved to a new home address or your house burned down and you had to get a new house somewhere. But you've got 30 days to notify the FAA of any permanent address change. And now on to part three, money and more. First is $175. That's the cost to take the Part 107 knowledge exam. So $175, that is a pass or fail cost. So even if you fail the test, you do not get that money back. So I would recommend studying and preparing adequately so that way you don't lose $175. And $5 is the cost for each individual drone registration. So if you remember back, you need to be at least 13 years of age to register a drone. And each drone registration is valid for 3 years. And it costs $5 to register each drone in your collection. The drones can be registered through the FAA Drone Zone website. 70%. That is the threshold that you must meet or exceed if you want to pass the Part 107 knowledge test. So there are 60 questions total on the test. That means you need to get at least 42 of them correct to earn that 70%. There's also a 14-day waiting period to test again after you fail. And just as a reminder, you would lose your $175 and have to pay that again after waiting that 14-day period. 0.04%. So any drone pilot, any drone operator needs to make sure that their blood alcohol level remains under 0.04% before they operate the drone. And speaking of operating the drone, they should only be operating one drone at a time. So unless you have some sort of waiver or special permission granted directly from the FAA, limit it to one drone per pilot. Part four, everyone's favorite sectional charts. Now, I'm not going to be getting into the nitty gritty on how to do everything there is to know with sectional charts, how to read them and understand every part of it. That's not the purpose of this video. Instead, I'm going to be focusing primarily on just some of the more prominent numbers that you're going to come across as you're looking at and reading sectional charts. So first up, 1 degree equals 60 minutes. Now, when you're looking at any particular figure that includes a sectional chart, you're going to see a line of latitude running east to west and a line of longitude running north to south. And you will see the degrees for each of those lines. Now, along those lines are individual tick marks. Each small tick mark represents 1 minute, and the medium-sized tick marks are going to be every 5th minute, and the larger-sized tick marks are every 10th minute. Now, if you're counting degrees, 60 of those minutes equals 1 degree. Here's what that means. This line of latitude is 40 degrees, and if I would count up 60 of these individual tick marks, that would put me at 41 degrees. And if I would count down south, that would then, if count down 60 of them, it would put me at 39 degrees. You stop somewhere in the middle, it would be whatever degree you're at, followed by however many minutes or tick marks that you counted. Airspace ceilings. When you're looking at these sectional charts, you're going to see a lot of different things, and one of them is going to be airspace indicators, which are usually circles, but not always, that are surrounding different airports on different areas of the country. Now, this particular airport here, you can see is surrounded with a dashed blue line, and there's the number 29 that is bracketed within that space. So bracketed numbers represent the ceiling of that airspace in hundreds of feet. And this is always in feet MSL or mean sea level. And they condense it to kind of conserve space on these maps because they're already busy enough. So since it's hundreds of feet, 29 add two zeros, telling us that is 2,900 feet MSL is the ceiling of this segment of Class D airspace. Something else that you're going to see with these airspace indicators is the airspace ceiling and floor numbers. These kind of look like fractions where you'll see a number on top of another number. The top number represents the ceiling of that section of whatever airspace it's within, and the bottom number represents the floor. And the SFC indicator that you'll see on this one would tell you that it is surface. These numbers also drop zeros, just like it did for the bracketed numbers on the previous number. So 80 over 25 would tell us that this particular section of Class B or Bravo airspace has a ceiling of 8,000 feet and a floor of 2,500 feet. Obstruction elevation. If you're looking at sectional charts and you see anything that looks like this, a small little triangle with a dot or anything that's similar to this, these represent obstructions. These are things that pilots need to keep an eye out for because they jut up off of the ground into the sky and can be a hazard. You're going to see two numbers next to these. The number on top represents the height of that obstruction in feet MSL, or mean sea level, while the number underneath in parentheses represents the height in AGL, or above ground level. Keep in mind that these are actual values and there are no dropped zeros here. Max elevation figure, or MEF for short. Now, these are numbers scattered around through all sectional charts that you're going to be looking at. And what these numbers tell you is the height of the highest terrain or obstacle in a certain area of the map. And it is given in feet MSL. So you can see the 9.6 on the left would be 9,600 feet, is how high the highest part of this ground juts up into the sky. Over here we have, this is actually 14.5, so part of that is covered, but it is 10 or 14,500 feet. So because of the mountainous region here, this area obviously goes up higher into the sky. And those are dropping zeros, so just remember to add two zeros next to the maximum elevation figures. Next up are military training routes, or MTRs. So you see on the left here are two different examples of what MTRs, or military training routes, could look like. They are oftentimes hard to find because it's just a light gray line with very small text and a small black arrow. Now, you're going to see some different letters and numbers along these routes, and just a little bit about what those mean. I stands for instrument flight rules. V stands for visual flight rules. The R stands for restricted. Now, getting down to the number is a little bit more of a coding here. So the three-digit numbers, so this is IR 425, a three-digit MTR route represents some sort of activity that's going to be happening at a higher altitude. So military training routes, we're going to have high-speed testing of aircraft or anything like that happening at a higher altitude, which is typically above 1,500 feet AGL. The four-digit codes here, so VR 1262, is representing something that's happening at a lower altitude, so typically below 1,500 feet AGL. Why they have the four-digit number being something that's at a lower altitude and a three-digit number being higher altitude, I don't know that, but this is what they mean. Something else you might see while looking at sectional charts are CTAF, or Common Traffic Advisory Frequencies. CTAF is a radio frequency used by pilots to communicate with each other at non-towered airports or when a control tower is not in operation. And the reason they do that is to ensure situational awareness and to allow for a safer flow of traffic. If you're looking for the CTAF frequency on any kind of airport indicator on a sectional chart, all you need to look for is the C symbol, which is a C inside of a circle. And it is going to be the frequency that is directly to the left of that C. So the CTAF frequency for Bishop Airport here is 123.0, and the CTAF frequency for Sacramento is 119.5. And just a little extra bit of information here. We have some magenta coloring on this airport and blue coloring on this airport. The magenta colored would be representing any kind of airport that does not have a control tower, while the blue text here represents one that does have a control tower. Another type of frequency that you may see is multicom. So the multicom frequency in the United States is 122.9 megahertz. Multicoms are used for self-announcing procedures at airports that either don't have a tower, they don't have a flight service station, or they don't have a unicom station. So multicoms can also be used as the CTAF frequency at airports that don't have those things. And now, part five, METAR and TAF reports. Congratulations, you made it to the final part. Take a deep breath, and we're going to move through this last part as you prepare to pass your Part 107 knowledge exam. Let's take a look at some more numbers. Now, before we go any further into looking at any actual METAR or TAF reports, I do want to mention that you should know your compass bearings. Now, when you're looking at this compass here, you should see the cardinal directions here, northeast, southwest, and the intermediate northeast, southeast, all that. But the degrees that are associated with each of these directions are something that you should definitely know. Now, I would really just make sure you know north, east, south, and west. So north being 0 degrees or 360 degrees, east 90, south 180, and west at 270. You can kind of figure everything else out. But you're going to see here when we look at the wind information for METAR and TAP reports, you're going to see degrees. And that is going to be what is telling us the wind direction. So it is essential that you know this information. In METAR and TAF reports, you're going to see a ton of numbers and letters that are very confusing if you don't know what you're looking at. And again, as with sectional charts, I'm not going to be getting into all of the details about how to read these. I am going to take a couple examples just to give you an idea of how these numbers work. And if you're looking to learn more about how to read TAF and METAR reports, I have some other videos on my channel that I'll throw links up to. So first, let's take a look at this segment here. 121720Z. And what that means at the beginning of each TAF report and METAR report, after they tell you what airport the report is coming from, they're going to tell you when the report was issued. So 1, 2, the first two numbers represents the day of the month. And the next four numbers, it's going to be the time. So 1720, and Z stands for Zulu, which is our 24-hour clock here. There's no AM or PM, so you have to know a little bit about this. But Z is your giveaway that we are dealing with time here. So 12-17-20Z is the 12th day of the month at 1720 Zulu. And for this mouthful of a number here, we're looking at another TAF report. It's actually the same TAF report. I do want to mention that this kind of information will appear on both TAF and METAR reports. This is not exclusive to TAF. Anytime you see a segment on one of these reports that includes the letters KT, you can know that is referring to wind. So pretty easy to tell. Looking down at this report here, I see a wind report right here because of KT. Another one right here that's highlighted in red. And then there are a couple more further down the report. Now, 33015G20KT, it's a lot. So to break this down, it is pretty simple once you get to know it. The first three digits always refer to the bearing, so that the compass bearing that I was talking about before, first three digits, here it's 330. And if you think back to that compass, we know that that would be a northwestern wind because it is almost at 360, which would be north. And just another little bit of information on that. If it's a single digit, it will have zeros. So a 7-degree wind would be indicated as 007. 40-degree wind would be 040. The next number following the three digits of the wind direction would be the wind speed. So 15 here would be telling us that there are 15 knot sustained winds. And then if there are gusting winds, you will see the letter G followed by the speed of the gusts. So 20 knot gusts. And if you ever find yourself confused over which speed is the gust and which one is just a standard wind speed, just look for the higher speed to be the gusting speed, because if it was not higher, it wouldn't be a gust. And all units here for wind speed are measured in knots. Okay, congratulations. You've made it to the end of the video. Obviously, that is not everything that you need to know to pass the Part 107 exam, but it should certainly help. And I want to end with a little bit of my advice for what I would say to anyone who is thinking about getting their Part 107 certification. First off, no matter where you are, whether you're just starting thinking about getting your exam, or if you've already kind of committed hours into preparing, Get a time slot scheduled for yourself. You can cancel it at any time as long as it's more than 24 hours out and there's no real obligation there. But what you can do is motivate yourself by getting a date in your calendar. That's what I did. I gave myself 2 weeks. I scheduled it 2 weeks in advance. And that really got me motivated to study even harder because that deadline was now approaching and I didn't have any other kind of hoops to jump through. It was all on me. Next, I would recommend rewatching this video multiple times, or maybe even just play it in your headphones or earbuds or something while you're driving, while you're running, while you're mowing your lawn or something like that, just to make sure you get these numbers down. And then also check out other Part 107 prep content. As I mentioned, this is not the only video you should be watching. It does not contain everything that you need to know. It's just primarily numbers based. There's a lot of other great content out there, including content that's on my channel that I'll throw links to. And then take practice tests. I do have a favorite practice test that I took multiple times actually that I feel really helped me prepare to pass the exam. And I'll throw a link to the King's practice test generator in the description of this video. And you should also work to strengthen your weaknesses. As you prepare and watch videos and take practice tests or anything like that, you're going to get familiar with content that you struggle with. Maybe it's sectional charts, maybe it's metar reports, maybe it's something else. But don't spend time rewatching, relearning content that you're already comfortable with. Take more time to strengthen your weaknesses. And if you do all of that and you put some honest effort into this, it's not going to happen overnight. You're going to have to spend some real time preparing. You can definitely earn yourself one of these, the Part 107 Remote Pilot Certificate. And just a last little reminder, if you do earn it, do not forget about that recurrent training. It's a real sad story when someone forgets and they have to spend that $175 again. So if you like this video, please consider liking, subscribe. It helps the channel. And I wish you all the best with your preparation for your Part 107 exam. And I will see you later. Thank you.